So the last section we are going to look at is 2.1. Generally, I split this up into 3 sections. We're only going to do 2 of them because of the half-day on Friday. So we'll do part 1 and part 2 of this section. All right, so we talked a little bit about distance and midpoint. The main reason for that was because square roots are going to come up a lot, and we need to be able to simplify square roots. We're going to see a little bit more with square roots tomorrow. Today we're going to talk about angles. So before we can even talk about an angle, we'll talk about something even simpler, which is what the 2 sides of an angle are called. And those are called rays. So a ray basically looks like this. It has a starting point called the vertex, and it continues in one direction forever. Here's another example of a ray. Now, if we take another ray, like that, and line that up with the first one, like this, what we've just created there is an angle. So if you put 2 rays together, just like that, you line the vertices up, so each vertex is right on top of each other. Then what we've created is an angle. So when you draw an angle all by itself, it's made up of 2 rays. Now if you draw a triangle like this, these 3 things right here, these are also considered angles. But these are not rays. Does anybody know what we call something that begins and ends somewhere? It doesn't go on forever? Yes? It's a segment. So when you're drawing a shape, where 2 segments meet, that is considered an angle. But when you're drawing something that's not a shape, just an angle all by itself, we generally draw it as 2 rays. And here's another example. 2 rays, starting from the same point, makes an angle. So when we draw an angle, it has 2 sides. It has an initial side and terminal side. So how do you know which side is which? Well, if you look at the 2 rays and you put yourself in between them, not outside them, but in between them, and you rotate counterclockwise inside the 2 rays, wherever you start is the initial, wherever you would end is the terminal. So you had an angle that looked like this. It's a little bit different. It's basically just that one rotated a little bit. Put yourself inside the 2 rays and rotate counterclockwise. Wherever you start, that's the initial. And wherever you stop, that's the terminal. We're going to have an easier way to figure out which side is which. Generally, we like the initial side to be horizontal. If we're going to draw an angle, we don't want the initial side kind of pointing up at on an angle. We want it flat. Okay, but that's how you can tell which side is which. Go between the rays and then rotate counterclockwise. Here's another example. That's how you would normally want to draw it. That's the best way to do it. Keep the initial side horizontal. rotate counterclockwise. Where you start is the initial, where you end is the terminal. Now, when we talk about measuring an angle, there's two ways we can rotate. Clockwise and counterclockwise. And depending on which way we rotate is going to control what kind of number you get. So, let me show you. Right, so here's a diagram that lets me draw different angles. It lets me put the terminal side wherever I want, but I can't move the initial side. That always stays right. If I start at 0 and I go in a counterclockwise direction, the angle that I get is a positive number. What do you think would happen if I started to go clockwise instead? Yep, if I start at 0 and I go clockwise, I get a negative number for my angle. Now there's two numbers here. One of them is degrees. The other one is something we'll talk about later today. So the only difference between clockwise and counterclockwise is whether you have a positive angle or a negative. So the important idea here, counterclockwise is positive, clockwise is negative. And just to make sure people know, we're going to use CCW as the abbreviation for counterclockwise. And counterclockwise is the opposite way that a clock goes. That's counterclockwise. This is clockwise. So I said earlier when we were talking about identifying the initial side and terminal side, we generally like the initial side to be horizontal. We don't really want the initial side pointing up at an angle like that. If we draw it so that the initial side is horizontal, that means that we've drawn the angle in what's called standard position. There's actually two things that have to happen for an angle to be in standard position. The first one is, if you have an XY axis, your vertex should be at the origin. And the second thing is, the initial side should be on the positive x-axis. It should be horizontal and pointing to the right. If those two things happen, then your angle is in standard position. There's an angle in standard position. So it gives us a way to draw something, and everybody's angle would look the same. So like if I said to draw a 45-degree angle, some people may have it rotated or flipped around, but if I said to do it in standard position, everybody's 45-degree angle should look the same. Now, let's say I did this. Just put that. Okay, is that still standard position? No? Why? What's wrong with it? The vertex is not at the origin anymore. Okay, the vertex has to be at the origin. The initial side is still on the positive x-axis, so that's good. But we need it at the origin. All right, how about if I did something like this? that down right about there. Is that standard position? No. What's wrong this time? It's what? What do you mean? Like what part of the definition is now messed up? Right, where the initial side is supposed to be where? It's supposed to be on the positive x-axis, and it's not. Okay, it's pointing up at an angle. The vertex is at the origin, so that's good. But we don't have the initial side where it needs to be. So standard position looks just like that. Any questions on that? Okay. So there's two different ways we can measure angles. One of them is degrees, and the other one is called radians. Has anyone used radians before or heard of them? So if you haven't, that's fine. If you have, well, that's good. But you might notice that when I draw these angles, you get two numbers here. One of them is degrees, one of them is radians. And then every now and then, all of a sudden, it changes to like a pi or something with a pi in it. So there are special angles along this circle, generally ones that are multiples of 30 or 45, that are written with a pi in it. If we just pick a random angle, then it's usually a decimal. But if we end up on one that's like a multiple of 30, like 30 itself, you're going to see pi. So radians has something to do with pi. And that's what I'm going to show you. So what we want to be able to figure out is this question mark. Okay, in a minute, I want to be able to erase that and put a number there. In order to know how to convert between two things, any two things, you have to start off with something that's true. For example, I wanted to convert between feet and inches. Can somebody tell me something that is true about feet and inches? I'd prefer something simple, but you could make it more complicated if you want. Yeah. That is something that's true. 12 inches equals 1 foot. So if I wanted to convert between feet and inches, I could do something like this. 12 inches over 1 foot. And then let's say I had like 8 feet, and I wanted to know how many inches it is. Just put feet in the same place it was on the other side. And you could solve for x by cross-multiplying. But the whole key to make that work was this. You had to start off with something you already knew was true. And if you didn't know this, you'd have to look it up, but you've got to figure this out somehow. There are 12 inches in a foot. Well, our 12 inches equals 1 foot is going to be this right here. We need to figure out how many radians in 360 degrees. And then we can figure out anything we want. Okay, just like this. Just because you put a 1 and a 12 here, does that mean I could only do 8 feet? Oh, could I do 7 feet? Yeah, I could do any amount of feet. It doesn't matter that I picked a 1 and a 12 on this side. You put any number you want right there. So it doesn't matter that I'm picking 360. I'm going to be able to use that to figure out any number that I want. All right, so if you look at the word radian, does it look like any other word that we use sometimes in like geometry? Radius. So radian and radius, there's a connection. First thing I'm going to show you is what a radian looks like as like a picture. And then I'll get into how do we convert between radians and degrees using a formula. So let's draw this circle. So what I've done this time is I've drawn a circle, and inside the circle I put an angle. Initial side, terminal side. And the two rays of the angle come from the center, and they hit the edge of the circle here and there. That's the 2 points where the angle contacts the circle. Between those two green dots is that shape in red. That shape is called an arc. An arc is just basically part of a circle. Any questions on that picture? Now, something very special happens if that angle is exactly 1 radian. And only 1 radian. It doesn't work if this angle is bigger or smaller. If that angle is exactly 1 radian, then the length of this arc in red and the length of that side of the angle and that side of the angle are exactly the same. They all come out the same. Since this side of the angle comes from the center and goes to the edge, what do you call something in a circle that goes from the center to the edge? It's the radius. So all 3 of those things, the 2 sides of the angle and the arc in red, would come out the same length. Only if that angle was 1 radian. And that's exactly what I just put right here. So it's kind of something special that can happen. If this angle is bigger than 1 radian, then it doesn't happen. If this angle becomes smaller than 1 radian, it doesn't happen. So that picture right there, that's pretty good. That's not like, it's not perfect, but that's a pretty good sketch of what a radian would look like. It's about that big. If you want to put a number on it, a radian is a little less than 60 degrees. I'll tell you exactly what it is in a little bit. It's a little less than 60. So this is good if you're a visual person. It kind of tells you what a radian could look like as a visual, but it still doesn't answer this question at all. It does not tell you how many degrees equal how many radians. Well, I can't really have you figure that out from scratch. You need to know something. It's like if I just kept asking somebody who didn't know how many inches in a foot, and I just kept asking them the same question. Well, they're not going to be able to figure it out unless they knew it before or they could look it up. Okay, it's not something you can calculate. Same idea with this. You've got to know something to figure that out. And this is the fact that I'm going to give you that's going to help us figure out how many radians in 360 degrees. It's not a very long sentence, but it helps us to figure it out. And it says that if you measure an angle in radians, it comes out the same as measuring something else. This something else is easier to measure. So if you measure an angle in radians, it will come out exactly the same as the length of the arc on a special kind of circle called a unit circle. A unit circle is just a circle that has a radius of 1. So this is a special fact about a circle that has a radius of 1. Right, let me draw that out so you can see it. So let's say that that circle has a radius of 1. And let's draw an angle in that circle. What that sentence is saying is that if you measure this angle in radians and you measure the length of this arc, they will come out exactly the same. How many radians in this angle will equal how many units in that arc. Those two things are always the same on this type of circle. So let's draw this. Same thing. How much? Well, what's that angle that I just drew in red? That's a 90. And how much of the circle? 90 degrees is how much of a circle? It's a quarter. This angle is 1/4 of the circle. This arc is also 1/4 of the circle. That's why I'm saying these two things would be the same. That's 1/4 of the circle as an angle. That's 1/4 of the circle as an arc. They're both 1/4 of the circle. Now, let's go a little bit bigger. How much is that angle? That's 180. If you measure this angle in radians, and then you measure this arc right there, they will come out exactly the same. I'm not saying this arc is 180, because that's in degrees. You have to measure this angle in radians. But if you measure this angle, like if you had a protractor, you put it on there and measure it in radians, whatever number you got for the sides of this angle, if you took a piece of string, measured that, and then put it on a ruler, the two numbers would come out the same. So now let's go even bigger. Let's say my initial side is here, and my terminal side is right there. So how big of an angle do I have this time? 360. I want to know what that is in radians. But there's something else I can measure that'll tell me how big that is. Instead of measuring the angle, let's find the length of the arc. Well, with 360, the arc gets pretty big. It's not a quarter circle. It's not a half circle. How big is this arc? It's a full circle. So as long as we can find out the length of a full circle, that's going to be equal to how many radians to go all the way around the circle. We just have to find the length of the full circle. Does anybody remember what the formula is for finding the circumference? Yeah? Pi r squared is the area. We are going to talk about that tomorrow. So hang on to that for 24 hours. Does anybody remember the circumference?
Isn't it like 2r?
Yep, it has those two things in it. 2 pi r.
Yeah, that.
So if we can find the length of the full circle, which the full circle is an arc, just a big arc that takes up the whole thing. If we can find the length of the full circle, that's going to be equal to how many radians to go all the way around the circle. So let's find the length of that arc. What's my radius in all these circles? 1. So let's fill in 1. And 2 pi times 1, that just gives me what? If we leave it in terms of pi. Yeah? 2 times pi. So that's about 6.28. So it's about 6.28 units to go all the way around that circle. 2 pi. Well, the length of the arc is equal to the measurement in radians. So if the arc is 2 pi, then the measure in radians is 2 pi. And that's the answer to our question. There are 2 pi radians to go all the way around the circle. So now we know a connection between degrees and radians. 360 degrees equals 2 pi radians. I'm going to write that down right here. Just need a little bit of space. So 360 degrees equals 2 pi radians. Okay, so that's fine. But that's kind of like saying to you that there are 180 seconds in 3 minutes. Although it's true, we can simplify it a little bit. Does anyone see what I could divide each side by? Yep, we could divide each side by 2, which means 180 degrees would equal what? Pi, yep. So that's better because it's a little bit more simplified. But we can do even better. By what? Yeah, what we usually do is when you give someone a conversion, you always give them a conversion with the number 1 in it. Like you might say there's 12 inches in 1 foot. You might say 60 seconds in 1 minute. You wouldn't normally tell somebody 240 seconds in 4 minutes. True? But you've made it more complicated. So let's get a 1 on one side of this equation. It doesn't matter what side. One way is going to convert degrees to radians. The other way is going to do radians to degrees. So I'm going to do what Sky suggested next. But what I want to do first is get a 1 on this side. What can you divide 180 by to make this left side a 1? Divide it by 180. So now let's see what it says. 1 degree equals pi over 180 radians. So there's a formula for exactly what 1 degree equals. 1 degree is pi over 180 radians. Now, we can use that formula to figure out everything we want to know. Let's say I wanted a formula for 2 degrees. I have a formula for 1 degree. What could I do on each side? Yeah? Right. If I multiply each side by 2, don't write what's in the box because I'm going to change it. But if you multiply both sides by 2, now it says 2 degrees on the left equals, and you have a calculation you can do out on your calculator on the right. And that's the formula for 2 degrees. What if I wanted a formula for 5 degrees? How could I modify the equation I have here for 5 degrees? I could multiply each side by 5. And now the formula says 5 degrees equals, and I have something I can do. The key is not what number you put in that box. You can put any number you want in the box. This is what's important. If you want to convert something from a degree to a radian, you do 2 things. You take what you want to convert, you multiply it by pi, and then you divide it by 180. Those are the 2 steps to convert from degrees to radians. Take and multiply by pi, and then divide by 180. Yeah. So that's degrees to radians. What we want to see is, can we get a similar kind of pattern from radians to degrees? Is there something simple we can do? So let's go back to what we had right here. 180 degrees equals pi radians. And now, instead of getting a 1 on the left side, I want to get a 1 on the right side. What could I divide each side by to get a 1 on the right? Divide by what? Just pi. Yeah, so divide just by pi. And Grady, when I do pi divided by pi, what happens?
Cancels out.
And what are we left with?
Just random.
How many? Just 1. Yep. So now this says 1 radian equals 180 divided by pi degrees. So I told you earlier that 1 radian was a little less than 60 degrees. What's that? No. 1 radian is exactly 56, well, not exactly, but about 57.3 degrees. That's what 1 radian is. Now, let's do the same thing. That's a formula for 1 radian. Let's say we wanted to know 2 radians. What could I do to each side of that equation so it gives me a formula for 2? Multiply by 2. Times 2 times 2. Now it says 1 times 2. So 2 radians equals 2 times 180 divided by pi. And what if I wanted a formula for 4 radians? I'd multiply both sides by 4. Again, it's not important what you put in that box. This is what's important. If you want to change from radians to degrees, there's 2 steps. Take what you want to convert, multiply by 180, and divide by pi. Multiply by 180, divide it by pi. So it's the opposite of what we did before. We're going to divide by pi. Now, because these 2 steps are very similar, it's pretty easy to mix them up. Right, is it divide by pi? Is it multiply by pi? Which one is it? Well, I can show you a way to remember it without even really having to memorize what we just put on here. And this is all you have to remember. When I say degrees, the number that I always want you to connect with the degree symbol is 180. So when I say degrees, think 180. Degrees, 180. When I say radians, I want you to think pi symbol. Radians, pi. So connect those 2 ideas. Degrees, think 180. Radians, think pi. If you can remember those 2 things, then all of that becomes automatic. Okay, let's try an example. So it says to convert 2 radians, 60 degrees. Might be helpful to think of it as 60 over 1. You may not have to do that eventually, but for what I'm about to show you, it might help. Whenever you want to convert between degrees and radians, or radians and degrees, you always multiply. You're either going to multiply by one of 2 things. It's either going to be pi over 180, or it's going to be 180 over pi. It's going to be one of the 2. Look at where degrees is in the fraction that's already there. Is degrees in the top or the bottom? It's in the top. Where do you think degrees would go in this fraction to cancel it out in that one? Where? Would go in the bottom. Because when you have the same thing in the bottom and the top of the fraction, it cancels. So degrees is going to go in the bottom. Radians is going to go in the top. What number did I say to always think of when you think degrees?
180.
Yep. 180. And when you think pi, or yeah. When you think radians, it's pi. Now we just cancel out and reduce everything we can. So degrees in the top, degrees in the bottom. What number goes into both 60 and 180? 30 does go even bigger. 60. How many times does 60 go into 60? And 180? 3. So this is what you're left with. 1 times pi over 1 times 3. And that's the final answer, pi over 3. Now, if you look at that, you might think I forgot something. Does anybody think that maybe I forgot to put something there that you thought was going to be after the pi over 3? The what? The radians, the label. You technically never write this label. I just did it the first time to kind of help you out, but you do not write RAD when you're really doing it. And I can show you on here. So if we go to 60 degrees, look at how they wrote. Does it say pi over 3 with the word RAD after it? No. That's because you don't put it. If something is in degrees, then yes, you need the little circle. That tells somebody that it's degrees. There's only 2 units we use. So if it has the little circle, then you know it's degrees. If it doesn't, then it has to be radians. Yeah.
So if it's written like that with pi on top, do you want us to like to the exact answer or just an answer like that?
So we're going to do some that are exact answers like these, and then we're going to do one that's going to be a round to 2 decimal places. So we'll do that one in a little bit. All right, let's try this 150. All right, so we've got degrees in the top. Tony, where's degrees going to go to cancel out? In the bottom. And Cameron, what's the number that we always put with the degree symbol? 180. And how about Sam? That means what's going to go in the top? Pi. Think of it this time. It says RAD, but it's invisible. Okay, we're not going to write it. All right, Gavin, what cancels out there?
Would the 150 from the 80?
Well, we're going to be able to reduce, but there's something that cancels out completely first. Same thing that canceled out in the last problem completely.
Is it the angle?
The degree symbol.
Yeah.
Yeah. So degrees in the top, degrees in the bottom. Let's cross that out. Now let's reduce our numbers. What goes into 150 and 180?
30.
30. How many times?
5.
And here? 6. So what's your final answer? 5 pi over 6. There you go. Yeah, I can show you that one too. So let's go to 150. 150. You notice it changed to 5 pi over 6. Any questions on that one? All right. Okay, let's try negative 45. Just because it's a negative, that doesn't change how we do it at all. It just means the final answer is going to be negative. Okay, so Ryan, where's degrees going to go?
Bottom.
Bottom. And Abigail, the number that we always put with degrees? Yep, 180. And if we put a 180 in the bottom, Naija, what does that mean is going to go in the top? The pi. Degrees in the top, degrees in the bottom cancels. And then just look at what you can reduce by. If you can't reduce, then you're done. But if you can, you should. 45. 45 goes into 45 once, and into 184. So the answer here, negative pi over 4. So if negative 45 is negative pi over 4, what do you think 45 is?
Pi over 4.
Pi over 4. Positive pi over 4. Any question on that one? So these are what we call exact answers. Okay, you're not plugging anything in, you're not writing a decimal. Let's do one where we round. So round to 2 decimal places. So 107 it's not really a nice angle. It's not a multiple of 30. It's not a multiple of 45. So when I show you guys 107 on this, it's not going to be a nice number with pi. You know, it's going to be some type of decimal. But the way we do it is exactly the same. We just need the calculator. Who can tell me what I'm going to multiply by to change that to radians? Yep, pi over 180. And this time we just do it out. Now, what is pi? What is it roughly?
3.14.
It's about 3.14. Is that the exact answer? No. So anytime we have a problem with a pi, we want to use as exact of an answer as we can. So on the calculator, like the ones that I let you guys use up front, there's a pi button on it. We want to use the pi button to do this. So you type it in just like this on my calculator. So 107 times pi, and then divide by 180. That's how we type it in. So it's about 1.87. Should I write RAD after it? No. Right, well, let's check it. Let's go to 107 on the other thing on the program and see if it says 1.87. So 107. There you go. 1.87. So any questions on changing from a degree to a radian? Okay, now the other way. Pretty much the same thing. Now on the first one, I will write RAD, just to kind of get used to it. But then after this problem, you got to get used to not seeing it. Okay, so we have pi over 6 radians. All right, first thing, radians is in the top. Where do we want radians to be this time to cancel out? We want it in the bottom. So you're going to put RAD. That means degrees is going to be in the top. And what's the number that we always put with the degree symbol? 180. And with radians? Pi. Now, before we reduce, let's just cross out anything that we can. Is there anything that's in the top and the bottom?
Yeah.
Pi, yep. Anything else?
6 and 180.
We can reduce that in a minute, but the radians, that's so all we're left with is 180 divided by 6. And what is 180 divided by 6? 30. Now, I already put the degree symbol, but could I have left the degree symbol off?
No.
No, because if I leave it off, what number is that?
30.
30 radians. Okay, if we're talking about angles and you're looking at a number without a label, it's radians. Now it's degrees. And we could just try it real quick here. Let's go to 30. There you go. 30 degrees is pi over 6. All right, let's try this one. 3 pi over 2, and then we'll do one where we round. Same directions. Convert from radians, 2 degrees. Okay. What's going to go in my fraction? Yep, so pretend that it says RAD after the pi. So write RAD in the bottom, but it's invisible. Pi radians in the bottom. 180 degrees in the top. Okay, and we can reduce this time. How many times? What goes into both 2 and 180? 2. 2 goes into 2 once, and that goes in 90. So you're left with 3 times 90 degrees. That's 270. That's how you convert from radians, 2 degrees, and those are exact answers. Any questions on those two? All right, let's try one more with a decimal. That'll be the last one. And let's see what happens if we use 3.14 compared to if we use the pi button. Most of the time when you round, it's going to be to 2 decimal places. So like if the answer is supposed to be 0.65 and you got 0.64, that's okay. But if it's supposed to be like 0.65 and you get like 0.73, that's not really okay. So let's see what happens. So what we want to convert this time is just 3 radians. Round to 2 decimal places. Okay. What's going to go in the top? 180 degrees. Yep. And in the bottom? Pi. Even if I could reduce something here, which I can't, I wouldn't worry about it because we're just going to type that all in on the calculator because it says 2. So round to 2 decimal places. So 3 times 180, it's going to give you 540. And now the first time I'm going to do it correctly. So divide by pi. That is the correct answer. So that's 171.89. About. Now instead of dividing by pi, let's use 3.14. And remember, we're supposed to be accurate to 2 decimal places. So let's take 540 and divide by 3.14. I get 171.97. Is 0.97 and 0.88 the same thing? No. Quite a bit off on that one. So, don't use 3.14. Okay, so any questions on converting between degrees and radians? All right. So that's the homework for tonight. I think there's 4 different kinds of questions. Some you're going to convert degrees to radians and you're going to round. Some you're going to convert degrees to radians, you're going to leave it exact. And then same thing for radians to degrees. Some you round, some will be exact. Okay, so we'll take a look at that tomorrow. And then we'll do part 2 of the section tomorrow. And the plan is to have our test on Thursday.